Hey Ramblers, this video is going to teach you how to classify triangles by two methods. We can classify them by the side length, or we can classify them by the angle measure. We're also going to see that there is one type of triangle which is kind of an overlap of both. Finally, we're going to learn the parts of an isosceles triangle and the parts of a right triangle. Okay, so take plenty of notes because this is more of a vocabulary lesson than it is a geometry lesson. Make sure you get all these definitions down onto cards so that you can memorize them. Okay, good luck, and I hope this video helps. Okay, let's take a look at the different types of triangles. There's really two methods for classifying triangles. The first is when we classify them by side length. The second is when we classify them by angle measure. So let's start with side length and take a look at three different types: scalene triangles, isosceles triangles, and equilateral triangles. Scalene triangles might be the most straightforward. Any triangle that has no congruent sides is scalene. So you'll notice that AB, AC, and BC all have different lengths, and that's what makes this a scalene triangle. No matter how I manipulate it, so long as these three side measures are not congruent, then it remains a scalene triangle. Now, if two of the sides did become congruent, and it's kind of hard to get it here on the computer to get them to be exactly congruent, but if they did become congruent, then it would no longer be a scalene triangle. We would have an isosceles triangle. So an isosceles triangle is a triangle that has at least two sides congruent. So here you can see DE and FD are congruent. That's what makes it isosceles. Now, an isosceles triangle has several different parts which we'll need to know to be able to identify. Now, the diagram gets kind of crowded here. We'll try and work you through it. Let's take the angles first. The angle that is between the congruent sides is known as the vertex. So angle EDF is the vertex angle of this isosceles triangle. The two congruent sides are called the legs. So ED is a leg and DF is a leg. Finally, the side that's not a leg, or it's opposite the vertex, is known as the base. FE is the base. Okay, now let's take a look at what some of the angles are called in a isosceles triangle. Well, we've talked about the vertex, but we also have two base angles. Angle FED and angle EFD are base angles of an isosceles triangle. They are opposite the two congruent legs. So we would say that ED is opposite angle EFD and DF is opposite angle FED. All right, let's move on then to the last triangle when we classify by side length, being the equilateral triangle. Now, the equilateral triangle has, as the name suggests, three congruent sides. No matter how we manipulate an equilateral triangle, all the side lengths will remain the same. That's what makes it an equilateral triangle. Okay, let's move on then over to the different types of triangles we have when we classify by the angle measure. The first of these is an acute triangle. An acute triangle has three acute angles. So as we manipulate the different, any way we manipulate the triangle, you'll notice that the three angle measures stay less than 90. If one of the angle measures did become 90, it would no longer be acute. It would become a right triangle. Now, right triangles have one 90-degree angle. Of course, you can't have more than one 90-degree angle, or else you'd have more than 180 degrees in the triangle. And that's not possible in Euclidean geometry. But we also need to learn some of the parts of a right triangle. So the side opposite the right angle is known as the hypotenuse. It's the longest side. The two sides of the right angle are known as legs. So we have leg HI and leg GH. Now also look at obtuse triangles. Obtuse triangles are a triangle that has one obtuse angle. Of course, just like with right triangles, we can't have more than one, or we'd have more than 180 degrees in the triangle. You'll see that angle QRS has 135 degrees in the angle. As we manipulate it, as long as it stays above 90, that remains an obtuse triangle. Okay, well, what happens if all the angles of the triangle are congruent? And that brings us back to an equilateral triangle. It's kind of the overlap between the two methods. You recall that an equilateral triangle has three congruent sides. Well, you may have noticed when looking at the isosceles triangle that opposite the congruent sides there are congruent angles. And so in an isosceles or an equilateral triangle, you can manipulate the sides of the triangle and they'll all remain equal. The angles are always equal and will always equal 60 degrees. So no matter how we manipulate the triangle, the angle measures will stay just 60 degrees. And that's the definition of an equiangular triangle. If all the angles of a triangle are congruent, then the triangle is equiangular. We also refer to a triangle that's equiangular or equilateral as being regular. And that is more general to all polygons that have congruent sides and congruent angles. They're known as regular. Okay, so you picked up 7 different new names for triangles based on their side length or their angle measure. And we also learned the definitions, or we saw some examples of the different parts of an isosceles triangle or a right triangle. Be sure that you have these memorized and that you're studying these, or certainly at least taking notes on this, so that you're ready for the exercises. I hope this helped, and good luck.